In this video, we will look into the next part of this vector embedding, and we will also look how to perform this clustering on text embedding to discover hidden structures and in the unlabeled data. Imagine you have a collection of text documents which includes description of customer feedbacks or some articles, and you already have converted them into embeddings, which we have seen in the last video. Now we want to automatically group similar pieces of text together without any. So now challenge is to automatically group similar pieces of the text that we have seen earlier into labels, and right now we don't have any. So we will be using unsupervised learning, especially k-means clustering, and we will walk through all the steps in doing that. We'll convert the embeddings into a usable matrix, then we'll find the optimal number of clusters, perform clustering, and finally visualize those clusters in a 2D format using the TSNE library. So going through the libraries, we will be using NumPy, Pandas, scikit-learn, matplotlib, and from the modeling perspective, we will be using k-means as our clustering algorithm and TSNE for visualization. At a high level, the workflow will be to start with the text embedding, which we store in a data frame, stack them into a numerical matrix, try different cluster sizes and evaluate each of the cluster, then choose the best cluster using the sellout score, then assign cluster labels to each data point, reduce the high dimensional embeddings into a 2D format, and then visualize the clusters. So let's quickly go through the code. We will be firstly preparing the embedding matrix. Here the df1 contains our embedding, where each row is a vector, typically output from a language model like we saw from sentence transformer. Then we are using np-vstack to stack all these vectors vertically to form a 2D matrix, where each row is a data point and the column is the embedding dimension. This helps us verify the dimensions are correct, which is achieved through this code statement. So let's see how we do this. We achieve this by converting the NumPy array into a PD pandas data frame. Now we do this step because it makes inspection and debugging easier. Then we import sklearn libraries. sklearn requires us to specify the number of clusters, and to do that we will actually first be evaluating different choices. So we are taking a range from 2 to 10, and we try that each cluster size using this for loop. We fit k-means model for each of the cluster size, compute the sellout score. A higher sellout score indicates better clustering. So here we are getting best cluster size as 3 for the training. We'll then use our best cluster size, that is 3, to train our model. We will extract the cluster labels and store them back in the original data frame, which is df1. Now since the embeddings are in a higher dimensional format, we cannot visualize this, so we will be requiring TSNE library to reduce them to 2 dimension while preserving the local structure. So this TSNE converts our embedding matrix into a 2D coordinates. So this converts our embedding matrix into a 2D format, and then we will be plotting the clusters. We are providing the colors for each of the clusters. We can remove one color since we are only limiting the size of the clusters into 3. Each color represents a different cluster. We also plot the centroid of the cluster using the X marker. The final plot will look like this, so it gives the intuition of how well the clusters are separated. So to summarize, we have clustered text embedding using k-means, used sellout score to choose the number of clusters, and then visualize the result using TSNE. This pattern embedding clustering and visualization is extremely powerful and widely used for topic discovery, document organization, and semantic search. If you like the video, please share and subscribe. Thanks for watching and happy coding.